Last lesson we looked at headlands and bays and how erosion can create those landforms. We thought about how resistant rock can create headlands and how less resistant rock can create bays. As the specification shows, we also need to think about the characteristics of other landforms, not just headlands and bays. We also need to consider cliffs and wave-cut platforms, and also arches, caves and stacks, which we'll look at further in other lessons. Erosion creates lots of features along the coastline. We've already looked at headlands and bays. Today we're going to think about cliffs and wave-cut platforms, and we're going to come back to caves, arches and stacks in other lessons. In order for the sea to erode, it erodes using 4 different types of processes, which I'm just going to explain about. The first is hydraulic action. This is where the force of the water and the air that might be mixed up in the wave of the water hits the rock, and the force of that water and air being pushed into little cracks in the cliff face causes that rock to break apart and to shatter. Obviously, if waves are hitting a cliff face several times a minute, there's a lot of opportunity for erosion to be taking place using this method, particularly if the sea is rough and has got a huge amount of energy. The second is abrasion. Abrasion involves stones and material rubbing against each other and wearing them down. If you imagine 2 rocks rubbed against each other, over time these 2 rocks will become smaller and smoother due to that abrasion taking place. Thirdly, attrition. Attrition where rocks hit each other. Again, this could be rocks in a wave hitting each other. As they do so, bits of the stone can break off and those stones can become smaller and again can become smoother. Or it could be a stone in a wave being thrown against a cliff face. Again, if you imagine throwing a stone at a cliff face, you can think about how pieces of the cliff and the stone may break, and this is another type of erosion that's taking place all the time. Fourthly is solution. In solution, this involves the stones dissolving away due to chemicals. In this case, salt that's in the seawater is going to cause rocks to break down slowly over time. With all these types of erosion, they will obviously happen quicker if the material is softer and less resistant, or will take a lot longer to erode if the material is much harder. What you now need to do is to produce a diagram that shows each of these 4 types of erosion. With each diagram, you need to draw how you would try and show this type of erosion taking place, and underneath each diagram explain the type of erosion. So the first type of erosion you might want to draw is hydraulic action. Here's my version of this. We've got a cliff with a crack in it. The waves are going up and down and the waves are hitting that crack. As they do, the water is being forced into the crack, and gradually over time the crack is being pushed apart, as can be seen by the 2 red arrows. Secondly, we've got abrasion. Here we have got 2 stones, 2 fairly rough stones. Those 2 stones are rubbing against each other. Over time, from rubbing against each other, those 2 stones have started to become smoother. Thirdly, we've got attrition. Again, 2 stones, fairly rough. Those 2 stones bash into each other, again as can be seen by the red arrows. Over time, with those 2 stones having hit each other, pieces have broken off. So that stone becomes smaller and smaller as attrition repeatedly takes place. Diagrams like this can help you remember those 4 different processes. Rather than just writing down a definition, a picture is a good way to help you remember that taking place. you might want to use these diagrams to help you with your piece of work. On the right hand side of the page is a YouTube clip thinking about what we've looked at so far. If you watch this clip from 5 minutes 30 to 7 minutes 14, you'll be able to understand a little bit more about the impacts that erosion has when it affects cliff faces. Erosion is just one type of thing taking place at the coastline. Obviously, we looked at weathering in previous lessons, and this is also having an impact on the coast. In the first picture here, we've got a cliff, we've got rainfall at the top of it, water making its way down through the cliff. That rainfall is making our cliff much wetter and heavier, and the material is finding it very easy to be able to slip down under gravity towards the sea. Also at the bottom of the cliff has been attacked by the sea and it's wearing away at the base of that cliff. Gradually, over time, the rock becomes increasingly unstable and starts to slump down the cliff under its own weight. As that material reaches the sea, it's then carried away by the sea and removed. This process happens repeatedly over and over again, with the sea hitting the base of the cliff, and over time the cliff retreats inland. Any property that's on that cliff is going to become increasingly vulnerable because the cliff is going to retreat away from the sea and land is going to be lost. That process then repeats itself as more material is carried away to the sea. This cycle is known as a Suss cycle and works in 4 stages. The ground becomes saturated. The ground is then undercut by waves hitting the base of the cliff. Material that is on the cliff slumps down or slides down towards the sea. And then material is transported away by the sea. And then the process repeats itself over again. And over time, the cliff will move inland. What you now need to do is to make use of the worksheet that's in the links on the right hand side. With that worksheet, write into the spaces provided using the statements to complete your version of the diagram you've just seen. Obviously, if you need some help, go back and have a look at what we've just looked at to help you complete those spaces on the sheet. Hopefully in the end you may have got something like this with your labels all added on correctly. If you've not, check your answers, correct any mistakes, and then keep a record of your sheet. One of the things we've just seen on the last sheet was the idea of undercutting. So we're going to try and understand a little bit more about undercutting in order to understand 2 landforms called wave cut notches and wave cut platforms. The diagram on the right we're going to look at and try and understand what is taking place. The idea with wave cut notches, undercutting and wave cut platforms is a fairly simple idea where the sea hits the base of the cliff. The sea repeatedly hitting the base of the cliff causes a wave cut notch to be created. This is created by the types of erosion that we looked at earlier, such as hydraulic action and attrition. The wave cut notch gets bigger and bigger, and the cliff above it is not supported. Because of this, the cliff then collapses into the sea and the material is carried away by the waves. The waves then continue to make the wave cut notch bigger again. Again, cliffs aren't supported, they collapse into the sea, and the process repeats itself. Over time, the cliff moves back inland and leaves behind the wave-cut platform. If you've ever been to the seaside and the tide's been out, you'll often find a wave-cut platform is where there are lots of rock pools in the rock, which you might paddle around in, and that is where the cliff used to be. As you can see in this clip here, a very small example of a cliff face, but the waves on the right hand side are repeatedly rubbing at the base of that rock, and you can see the wave-cut notch being created by those waves. And all that is happening there is repeated abrasion, is rubbing away at that rock, making that happen. More and more that takes place, the rock above will not be supported, and eventually that will collapse, even on a very hard rock like the one you can see here. Okay, so we want to be able to draw this diagram. We want to be able to see how undercutting and wave-cut notches can be created. So a very simple diagram, something like the one that I've drawn on the slide. We've got a cliff, and we've got the sea at the bottom of it. We've also got the wave-cut notch starting to be created. A few labels on here, so we've got undercut and we've got wave-cut notch, and the red arrows showing where that cliff is being eroded away and the wave-cut notch is being made bigger. Gradually, the cliff is not supported, it's shown there by the dotted line. This material is going to fall into the sea, and our cliff is then going to move backwards inland. Once that's moved inland, and a little bit further on, the cliff has moved in. Again, we've got a new cliff face, we've got a wave-cut notch, and the sea is going to be eroding away at the base of that cliff. The process will repeat itself. The cliff's not supported, it will fall into the sea, and the cliff will move back. Again, the process repeats itself. The sea is wearing away at that wave-cut notch, wearing away at the cliff face, and by this repeated action over and over and over again, we've got our wave-cut platform being created at the base. Okay, what you now need to do is you need to draw yourself a diagram. Onto that diagram, you need to make sure you add labels that show things such as where the cliff is, how it retreats, the wave-cut notch, where the cliff was originally, where the water would be at the high water mark, and where our wave-cut platform is. As well as the labels, which you could write on directly or you could write on with numbers, you also need to write an explanation as to how this feature has been created. This slide may give you some help in order to be able to write that explanation. Think about using the words in the purple box. A better answer is going to include keywords such as attrition and hydraulic action. That obviously is more specific than just talking about erosion. It's going to give you a more detailed answer, and therefore in an exam going to get you more marks. Having written your answer, you may want to look at this in order to think about things you may not have included and whether you could add to your answer and improve it. And our final task, we're going to answer this exam question. Explain how headlands and bays form. Now, we looked at headlands and bays last lesson. We've thought today about erosion. So using our knowledge from previous lesson and from today's work on erosion, we should be able to write an answer for this question. Note the question, the command word is explain. It's a 4-mark question. It was not going to be a very long answer, but you want to be able to be writing to the point about how headlands and bays are formed. Think about the command word asking to give reasons why something's happened. It wants the causes. It wants the things that have created this to take place, and it wants to show that you understand the process that is happening. Good way to start this could be headlands and bays form when, and words that you could try and think about including could be the ones we've looked at in recent lessons, such as hydraulic power, resistance, bay, discordant abrasion. Obviously other words you might choose to include as well. Looking to get to 3 to 4 marks, you want to be able to have statements that are explained. So you're trying to explain how hydraulic action might be causing headlands and bays to form, or how and why certain rocks may be more resistant. Write your answer and then come back to the mark scheme to think about whether you've included all the relevant points.